Picture this: you're sitting here right now, listening to these words. A moment ago, you weren't. In a moment, this sentence will be in your past. This experience, this flow from future through present into past, feels so real, so fundamental, that questioning it seems almost absurd. But what if I told you that everything you think you know about time might be wrong? Time is perhaps the most mysterious aspect of our existence. We experience it, we measure it, we organize our entire lives around it. Yet when scientists and philosophers dig deeper into the nature of reality, a startling question emerges: does time actually exist? Today, we're going on a journey through the looking glass of modern physics, into the depths of consciousness, and to the very foundations of reality itself. Let's start with what seems obvious. Right now, as you listen to this, you're experiencing what we call the present moment. You have memories of breakfast this morning, that's the past. You might be thinking about dinner tonight, that's the future. This feels natural, doesn't it? Time flows like a river, carrying us from past to future. We age, seasons change, cause precedes effect. How could anyone question something so fundamental? But here's the thing about science: it has a habit of showing us that our most basic intuitions are spectacularly wrong. Think about this: right now, you feel perfectly still. But you're actually spinning on a planet that's rotating at over 1,000 miles per hour, while hurtling around the Sun at 67,000 miles per hour, while our entire solar system races through the galaxy at 500,000 miles per hour. If we can be so wrong about motion, what else might we be wrong about? What if our experience of time flowing is just another cosmic illusion? This question isn't new. Long before our modern scientific tools, philosophers were already wrestling with the deep strangeness of time. Long before Einstein revolutionized our understanding of time, humanity's greatest thinkers grappled with its nature. Their insights remain remarkably relevant to our modern quest. In the 4th century, St. Augustine posed a question that still haunts philosophers today: what then is time? If no one asks me, I know. If I want to explain it to someone who asks, I do not know. Augustine noticed something peculiar about time's structure. The past no longer exists, it's gone. The future doesn't yet exist, it hasn't arrived. So only the present exists. But what is the present? The moment you try to grasp it, it's already become the past. Augustine concluded that the present has no duration, it's an infinitesimal point between non-existent past and future. This led him to a radical insight: perhaps time exists only in the mind. The past exists as memory, the future as expectation, and the present as attention. Time, Augustine suggested, might be a feature of consciousness rather than reality itself. Aristotle took a different approach. For him, time was intimately connected to change and motion. Time is the measure of change, he declared. Without change, there would be no time. Without time, there would be no change. But Aristotle faced his own puzzle: if time measures change, what measures time? He proposed that time is measured by regular, cyclical motions, like the rotation of celestial spheres. This view dominated Western thought for nearly 2 millennia and still echoes in how we measure time today with clocks and calendars. Immanuel Kant revolutionized philosophy by arguing that time isn't a feature of the world itself, but rather the fundamental framework through which we experience reality. Time, along with space, is what Kant called a pure form of intuition, a necessary structure of human consciousness. According to Kant, we can't experience anything outside of time because time is the very condition that makes experience possible. This doesn't mean time is subjective in the sense of being arbitrary or personal. Rather, it's a universal feature of how conscious beings like us must experience reality. Kant's insight was profound. Perhaps the question isn't whether time exists out there in the world, but whether we could ever experience a world without the framework of time. Henri Bergson drew a crucial distinction between two kinds of time. There's mechanical time, the time of clocks and physics, divisible into equal units, measurable and quantifiable. But there's also lived time, the time of consciousness, where moments can feel eternal or flash by in an instant. Think about how time seems to slow during a crisis or speed up when you're absorbed in something you love. Bergson argued that this subjective, qualitative time, what he called durée, is more fundamental than the mechanical time of science. For Bergson, real time is creative, flowing, and indivisible. It's the time in which genuine novelty emerges, where the future isn't just a rearrangement of the past but something genuinely new. This view would later influence thinkers grappling with consciousness, creativity, and free will. Martin Heidegger took the philosophical investigation of time in yet another direction. For him, time isn't just something we experience, it's fundamental to what it means to be human. Heidegger argued that human existence is essentially temporal. We're always projecting ourselves into future possibilities while carrying our past with us. Our present is meaningful only in relation to our past experiences and future projects. We don't just exist in time, we are temporal beings through and through. This led Heidegger to distinguish between ordinary time, the time of clocks and schedules, and primordial temporality, the deeper temporal structure of human existence. Understanding this deeper temporality, he argued, is key to understanding what it means to be human. British philosopher J.M.E. McTaggart presented one of the most famous arguments against the reality of time. He distinguished between two ways of ordering events. The A-series orders events as past, present, or future, a dynamic ordering where events move from future through present to past. The B-series orders events as earlier than, simultaneous with, or later than other events, a static ordering of temporal relations. McTaggart argued that the A-series is essential to time as we understand it, but the A-series leads to contradictions. Every event is simultaneously past, present, and future, just at different times, which seems contradictory. His conclusion? Time is unreal, a persistent illusion of consciousness. These philosophical investigations reveal that the question, does time exist, has been puzzling humanity's greatest minds for millennia. Each philosopher illuminated different aspects of time's mystery. Augustine showed us the puzzle of the present and suggested time might be mental. Aristotle connected time to change and motion. Kant argued time is the framework of experience itself. Bergson distinguished lived time from measured time. Heidegger revealed time as fundamental to human existence. McTaggart questioned whether time could be real at all. What's remarkable is how these ancient insights anticipate and complement modern physics. Augustine's suggestion that time might be mental resonates with theories about consciousness creating temporal experience. Kant's view of time as a framework echoes relativity's revelation that time is relative to the observer. Bergson's distinction between lived and measured time parallels the difference between subjective experience and physical time. The philosophers didn't solve the mystery of time, but they mapped its contours and showed us why it's so puzzling. They prepared the ground for the scientific revolution that was to come, a revolution that would make their deepest insights seem almost prophetic. Enter Albert Einstein, a man who would shatter our understanding of time forever. Picture the year 1905. The world thinks time is absolute, universal, the same everywhere. Like a cosmic metronome, ticking away uniformly throughout the universe. Then this young patent clerk publishes a paper that changes everything. Einstein tells us something incredible: time is not what we think it is. It's not separate from space, they're woven together into something called space-time. And here's the kicker: time is relative. Imagine you're on a train approaching the speed of light. To someone standing on the platform, your time would slow down. What feels like an hour to you might be years to them. This isn't science fiction, this is reality. GPS satellites orbiting Earth right now have to account for this effect, or your navigation would be off by miles. The practical implications are staggering. Today, we live in a world where time is meticulously synchronized across the globe using Einstein's insights. The International Atomic Time, TAI, serves as our most precise time standard, based on the vibrations of cesium atoms, so accurate that it would take 100 million years for these atomic clocks to drift by just 1 second. The Global Positioning System satellites, orbiting at 20,200 kilometers, constantly broadcast precise time signals that account for both special and general relativistic effects. Your smartphone receives these signals to keep time accurate to within microseconds. This global time synchronization, crucial for everything from international banking to internet communications, exists only because we understand Einstein's revelations about time's malleable nature. We've learned to work with time's relativity, even as it challenges our deepest intuitions. But Einstein wasn't done. 10 years later, he delivers another bombshell. Gravity doesn't just pull on objects, it warps space-time itself. Time literally runs slower in stronger gravitational fields. We've tested this. Atomic clocks at different altitudes tick at different rates. Time at your feet runs slightly slower than time at your head because your feet are closer to Earth's gravitational center. Think about what this means. Time isn't the universal stage we thought it was. It's part of the very fabric of reality, a fabric that can stretch, compress, and curve. But Einstein's revelations led to an even more startling conclusion. Now comes the truly mind-bending part. Einstein's discoveries lead to a conclusion so strange, so counterintuitive, that even Einstein himself struggled with it. What if I told you that right now, this very moment, your childhood birthday party is happening? What if your future death is occurring simultaneously with your birth? What if every moment that ever was or ever will be exists right now, frozen in a four-dimensional block? This is called the block universe. Imagine reality as a vast, four-dimensional loaf of bread. Each slice represents a moment in time. From our perspective inside the loaf, we experience one slice at a time, that's our present moment. But from outside the loaf, all slices exist equally. Your first kiss, the extinction of the dinosaurs, the birth of the last star in the universe, all equally real, all equally now from the universe's perspective. But wait, this can't be right, can it? Surely only this moment is real. The past is gone, the future hasn't happened yet. This view, called presentism, matches our experience perfectly. So which is it? Are we living in a flowing river of time, or are we frozen in an eternal block where everything that ever happens is always happening? The answer to this question doesn't just affect physics, it strikes at the heart of free will, moral responsibility, and what it means to be human. Yet the strangeness doesn't end with relativity. Just when you thought things couldn't get stranger, along comes quantum mechanics, the theory that describes the bizarre world of atoms and particles. And it has its own weird relationship with time. Picture an electron. In the quantum world, before you measure it, that electron doesn't have a definite position, it exists in what we call a superposition, simultaneously in multiple places at once. Only when you observe it does it collapse into a single location. But here's the puzzle: how long does this collapse take? It seems to happen instantaneously, but how can anything happen in zero time? And if it takes some time, what determines how long? Then there's quantum entanglement, what Einstein called spooky action at a distance. Two particles can become entangled, and measuring one instantly affects the other, no matter how far apart they are. We're not just talking faster than light, we're talking instantaneous. But if time is relative, as Einstein showed us, what does instantaneous even mean? Instantaneous according to whom? Here's where it gets really wild. Some physicists, trying to merge quantum mechanics with Einstein's relativity, have written equations that describe the entire universe, equations with no time in them at all. Think about that. The fundamental equation of reality might not include time. It's as if time is just something that emerges from deeper, timeless processes, like how wetness emerges from H2O molecules, even though individual molecules aren't wet. This raises a profound question about time's very nature. But wait, if the fundamental laws of physics work the same forwards and backwards, why do we experience time flowing in one direction? Why do we remember the past but not the future? Why do eggs break but never spontaneously reassemble? The answer lies in something called entropy, a measure of disorder. And here's the key insight: disorder tends to increase over time. Imagine dropping a glass. It shatters into 1,000 pieces. Those pieces could, in principle, spontaneously leap back together to reform the glass. The laws of physics don't forbid it. but the odds are so astronomically small that it will never happen in the lifetime of the universe. This is why we have an arrow of time. Not because time itself has a direction, but because the universe started in a highly ordered state, the Big Bang, and has been becoming more disordered ever since. So the flow of time that feels so fundamental to our existence? It might just be a statistical accident, a byproduct of the universe's journey from order to chaos. Time's arrow isn't carved into the fabric of reality, it emerges from the statistical behavior of countless particles moving from order toward chaos. So where does this leave us? Many of today's leading physicists are converging on a radical idea: time might be what we call emergent. Think about temperature. When you touch something hot, you feel heat. But zoom into the molecular level, and there's no such thing as hot, just molecules moving fast. Temperature emerges from molecular motion, but it's not fundamental. What if time is like temperature? What if it emerges from something deeper, something timeless? Some theories suggest that spacetime itself is made of tiny, discrete pieces, like pixels on a cosmic screen. Time might emerge when these pieces interact in certain ways. Other theories propose that time emerges from information, from the universe's constant computation of its own next state. In this view, time is the universe thinking. Imagine that, time as the universe's way of processing information, of computing its own existence moment by moment. But perhaps the most surprising insights about time come not from studying the cosmos, but from studying ourselves. But let's step back from the cosmic and quantum for a moment. Let's talk about you, about the time machine sitting between your ears. Right now, you think you're experiencing the present moment. But neuroscience tells us something fascinating: there is no single present moment in your brain. What you call now is actually a construction, a story your brain tells by weaving together signals that arrived at slightly different times. Your brain takes about half a second to construct what feels like the immediate present. You're always living in the past, but your brain edits out the delay. And here's something even more remarkable: without memory, you couldn't experience time at all. Patients with severe amnesia don't just forget the past, they lose the sense of time's passage entirely. They live in an eternal, disconnected now. So maybe the flow of time isn't out there in the universe. Maybe it's in here, in consciousness itself. Maybe time is something minds do, not something the universe is. What if the universe is timeless, and time is just the way conscious beings experience reality? What if time is the signature of awareness itself? These questions bring us to the deepest implications of our journey. Now we come to the heart of the matter. These aren't just abstract physics questions, they cut to the core of what it means to be human. If the block universe is real, if all moments exist equally, then what happens to free will? Are you really choosing to listen to these words, or is that choice just an illusion created by your position in the block? If your future decisions already exist somewhere in spacetime, are you truly responsible for them? And what about you, your identity, your sense of self? If time doesn't flow, what connects the child you were to the person you are now to the elder you'll become? Are these different people, or the same person extended through time? Here's perhaps the deepest question: does life have meaning if every moment, your birth, your struggles, your triumphs, your death, exists eternally in the block universe? Or does meaning require genuine change, real becoming, the authentic flow of time? These questions don't have easy answers. They may not have answers at all. But they force us to confront what we really believe about choice, identity, and purpose. So where does this leave us? After this journey to the edges of physics and philosophy, the fundamental question remains: does time exist? We've seen that time is not the simple, universal river of our intuition. It's a malleable fabric woven into space, warped by gravity. We've learned that its forward arrow might be nothing more than the universe's slow, inevitable slide into chaos. We've explored the stunning possibility that our experience of time's flow is a story told by our own minds. And we've confronted the notion that at the most fundamental level, reality may be timeless. And yet, you still need to catch that train. you still feel the joy of a memory and the anticipation of a dream. Regardless of whether time is real or illusory, it remains the framework of our lives. The quest to understand it is far from over. Physicists search for a final theory of quantum gravity. Neuroscientists map the brain's construction of the present moment. And every one of us participates in this quest whenever we look at a clock and wonder. Perhaps we don't need to choose between the physics of a static universe and the feeling of a flowing one. Perhaps they are two sides of a reality too complex for any single viewpoint. The mystery of time is inseparable from the mystery of what it means to be human. So the next time you check your watch, or remember a moment from your past, or anticipate what's coming next, pause. You're not just experiencing time. You're participating in one of the deepest riddles of existence. Maybe the question itself is more important than the answer. Thank you for joining this journey through one of reality's greatest mysteries. The quest to understand time continues, and every moment of wonder brings us closer to the truth, whatever that truth might be.